Okay, hey, this is inverse variation. So, what inverse variation looks like this here. It's actually a rational graph, a rational function graph. You'll learn more about that. And it's defined this way. It's where x times y equals k, as long as k is a non-zero constant. Because makes sense because you have asymptotes there at the zero lines. All right. So here we go. And basically what it means is on direct variation, you had y divided by x. Here, x times y equals the x2 times y sub 2. So if you divide each of these by x, basically y is equal k divided by x, which is where you get a rational function because you have x in the variable, in the denominator, variable. So the parent function is y equals 1 over x, which is kind of what this graph looks like right here. So, and what we have now is this here. And if you'll notice, you plug these numbers into the equation, like 1 times 1 is 1, 2 times 1/2, 3 times 1/3. Notice if you multiply these, all the answers turn out to be 1. 2 times 1/2, 3 times 1/3. That's what makes it a inverse variation. So when you multiply it, you get the same number, right? So if we want to work this out, so y varies inversely as x. So if y is 5 and x is 6, basically what we're going to do is we're going to take 6 times 5, which is 30, and divide it by the 2, which is 15, to get our answer. So if we work another one, here we have 8 and 5. It varies inversely. Notice the keyword there says inversely, not direct. This would be 8 times 5 equals the 10 times the y. So 5 times 8 is 40. Divided by 10 is 4. And let's do one more of these. So again, it varies inversely. So it's 2 times 10, which is 20. And I'm going to divide by 5/3. But how do you divide fractions?
Upside down, upside down, upside down.
Yeah, I got basically multiply with the reciprocal. 3/5. If you take 3 times 20 is 60, divided by 5 is 12. Inverse variations are multiplies. Direct variations are when you have the y1 divided by the x2, so they're a little different.